Hi everyone, I'm Ke. I'm so excited to be here to share my paper mTSeer, Interactive View Exploration of Models on Multivariate Time Series Forecast. It's a work about how to use visualizations to help model users to select their forecasting models. This is the agenda. The definition of multivariate time series forecasting means we make predictions with multiple time-dependent variables as input. For example, if we want to predict the New York air quality in the next few hours, of course we can use the previous AQI values as input, but a more meaningful way is to use other meteorological indicators that are highly related to the air quality index, such as the temperature and the pressure, to make predictions. However, making multivariate time series forecasting have some problems. First, with a variety of forecast models, which one is the most suitable for a given dataset? Second, we have different settings for the input time series. For example, we can choose different lengths as input time series. It may depend on the problem. There is an open question: if the input is a periodic time series, is it the best choice to set the length of input with the period? There are many other variables. In such a case, how to set these parameters to fit the model best? There are some related works. Some focus on specific models on multivariate time series forecasting, such as RNN. Other works are focused on general time series models, but most of them deal with univariate problems, so few works are related to general multivariate forecasting models according to our survey. Therefore, we present mTSeer to solve the problem. The system pipeline mainly contains 3 steps. We first set the input, and then feed the input into some candidate models. Finally, we use Shapley values to compare and explain different models by their feature contributions. This is the UI of mTSeer. It has 3 modules, from the model construction module to the model evaluation module and the instance analysis module. Here I will give more explanations to each view. For model construction, users first use the data selection view to select the training and testing data, respectively. We display each raw time series across a circular timeline. For the parameter view, we display a list of parameters for setting the forecasting models and the anomaly detection algorithm. Then we go to the model evaluation. The model overview aims at providing an overall comparison of different forecast models via the root mean square error and the summarized feature importance. The inspection view provides a detailed model-agnostic explanation for each module. As shown, this view can be divided into 3 parts: a line chart on the top that plots the raw testing time series, and the model explanation plots below that depict the detailed interpretation of each candidate model's performance in the temporal context, which can be switched from the current box mode to the bar chart mode. For the box mode, specifically, in each time step, we design box glyph to facilitate the exploration of feature contribution. Each box in the glyph represents one feature. The boxes stacked above the predicted value show features with a negative effect that push the forecast value lower, while those stacked under the predicted value are positive features pushing the value higher. The dashed line shows the ground truth, so we can check the gap between the ground truth and the predicted value to gain insights about the performance of different models. For example, by the overall mean squared error, RF is best. However, by checking the detailed performance at each time step, we find the reason that RF is better as it has similar prediction results at different time points, which makes its average error is smaller than others. However, in our case study, the experts still regarded the LSTM as the best model as it can fit the trend of ground truth value at most time. Its results are more meaningful in real applications. At last, when click one column of a model in the inspection view, each feature's historical importance and its trend will be displayed in an individual line chart to give more insights, like whether the recent data or the remote data are more important. The last instance view can show different type of relationships of the input data, such as prediction versus ground truth. We evaluate the effectiveness of mTSeer in multiple ways. First, we describe 3 case studies with real-world datasets. For each case study, we conducted a corresponding quantitative evaluation. For more details, please refer to our paper. Thank you.